Alright, if you are watching this, this is going to be a demo of Multisim and Ultiboard to make printed circuit boards. I see 4 people out there right now. The problem that we have with the live stream with let me see. Hold on. Okay, so I have a frame rate error someplace in here, so it should work. Anyways, if you're out there and the 22-second lag across or more on YouTube can cause some problems. So if you want to watch this on Hangouts, I've got Hangouts up as well. I think I just need a Gmail link, and I can send it to you that way. Other than that, I just wanted to start out. So the assumption here is that you have Multisim, and so I'm just going to, National Instruments Multisim is what we use here at Montana Tech, or at least what I use. There's lots of different ways to make printed circuit boards, so that's coming up. The other one that I'm going to open up simultaneously is Ultiboard, also made by National Instruments, and so I'm going to bring both of those over. Let me start by Multisim. So you may be familiar with Multisim because it's a very nice schematic program and it does simulation. And so we can place all sorts of components like a resistor. Okay? And I'm not sure, these have a whole bunch of different kinds of resistors that are out there. That's kind of interesting. I've never been through all of these different ones, but some interesting things to note here is it tells you the manufacturer, and it tells you the package. In this case, 0603 is familiar to me. It may not be familiar to you. Before we go too deep in, though, I wanted to just show you this. So I'll give you an example of something that I've built in the past using Ultiboard and Multisim. And this is a printed circuit board. It has an LCD on it. It has 2 chips, a voltage regulator, 2 USB connectors, an oscillator, and then on the back side is actually the LCD. I can show you a physical model of what this actually looks like. But this is kind of what we're going to get at. And this will be able to produce a Gerber file. So once again, if you're on the stream and you want to be on the Hangouts, go ahead and type in the comments. I guess you don't want to do that. You can email me. Email me your, and I'll be trying to pay attention to my email at this point. I think, I don't want to, okay. I'll pay attention to my email. It'll be on my screen up here. To be in contact. So what we're going to do at this point in time, I'm sorry that took so long, but what we want to do is we want to make something like this. This is a finished product that has a board outline. We also have lots of layers, and so just to show you the layers, the copper top is in green, and I'm just gonna kind of mute everything else to kind of give you an idea that we have a whole bunch of layers here that are associated with just the top layer. We can also select the bottom layer and mute the top layer, and so this is what the bottom layer of this printed circuit board looks like. And if that's not enough, I can do a 3D preview of this, and it kind of looks like that in real life. In fact, I have the actual thing here. It's a little bit distance away. I wasn't planning on grabbing it, but let me see if I can grab it here. There it is. I will show you approximately what this looks like in real life. And so hold on, and we'll get the video capture up. And you can see my messy desk. But this is what it actually looks like in real life. And so that diagram that's there, the schematic that they have, the 3D preview, looks an awfully lot like this once you get done. So what I'm going to do is go back to my video capture, my screen top capture here, and we want to be able to do something like this. Now, in the short period that we have today, we are not going to be able to do something that complicated. So everything starts here at Multisim. So let me see, we're going to place a component. Okay? Multisim is going to give us a schematic. It's a cartoon for what we've got. So I'm going to go to basic, and I'm going to find a resistor, something that we should be familiar with. Okay, and I picked a 1K, and over here are the packages. And so, just to give you an idea on packages, something that's kind of annoying but not taught is if we go in here, database manager, the footprints are housed in the actual packages are housed here in Ultiboard. So Ultiboard is what's going to give us the layout, not the schematic. And so I'm just going to come through here, find some resistors. Okay, and so let me see, did I do that right? Radial resistors. No, I don't want a radial. I want an axial. Okay, so these are different things. We can show dimensions. That's 578 mils. I like millimeters. 14.7 millimeters. So that gives you an idea of the different packages that are available for just through-hole resistors. Okay, so which resistor I have, go measure it. And so you can go and measure what it is from a pin to pin, or what the body approximately looks like, and it does that. Now, I'm kind of one of those guys that likes to do through-hole, but we can, sure, I'll do that one. We'll put that one down. I'm going to do another one with what I usually like to do, which is surface mount. I like those 603s. Okay, and so we've got both those guys placed, and I'm going to electrically place and connect these guys. Okay, we're going to save it. In fact, I don't even care. Let's save it. We'll save it in something that's pretty innocuous. Documents, National Instrument. Oh, how good is that? Okay, Design 1. Fine. I don't care what it's really called. And so I have R1 and R2. And if you remember, R1 is the one that has a through hole. This one is surface mount, and a lot of you are unfamiliar with the surface mount. But what I just showed you, if we go back, and all of my resistors that I had on this. So there's a couple of them. There's one here, and I think that's one there, and I like to use 0603s is what they're called. And this is teeny tiny. I mean, if you look at the size of this, if you look down the bottom right hand corner in mils, it's not very far apart. It's like a millimeter as far as what's that concerned. So going back to Multisim, what we're going to do is, now that I have my design, very simple, stupid design, I'm going to transfer it to Ultiboard. It's going to save it as the same thing. It's going to tell me all my components, all of my nets. A net is a connection. It's a node. And so you can see all the things that are in here. Net 1, how they're connected to how net 2 is connected, all the parts that are on there. And so we can see, so first we have this yellow board outline. And then I have my two components, and you can see the size difference of these. And there's also a faint yellow line. I'm using Control R to move them, to rotate. But you can see this faint yellow line that kind of moves with it. And what those are the actual connections here. So that's all nice. And also over here you can see that I can select to be on copper bottom, or keep in, keep out, or board outline, or silk screen top, or silk screen bottom. Right now, let's only worry about copper top and copper bottom. So now that this is there, this is physically what this is going to look like. And so if I go and view, and I do my 3D preview, yeah, this looks pretty boring. It looks like two resistors that are right next to each other. It physically makes this board, and I can resize. I'm going to select board outline, and this is one of the last things I do, but I'm going to come over here to board outline. I accidentally double clicked. I'm going to resize that, and once again I come up here and view my 3D preview. Now it's smaller, okay, and that's not surprising because I just made it smaller. But there's no copper between these. It says that they should be there, and so I'm going to go to copper top. I'm going to go place. Let's say I like where these are placed. By the way, there's this other stuff. This blue stuff is silk screen top. That's the white stuff that comes across on a printed circuit board. And so if you view your bird's eye again, not bird's eye, view my 3D preview, get rid of that one. You notice in yellow is how they're depicting the silk screen. That's actually, it doesn't do anything electrically, but it does give us the, it does give you which resistor goes there, and you can add silk screen. There's all sorts of fun stuff. Place, line. Now it's going to try to place a silk screen top line. I don't want to do that, okay? So I'm going to just get out of that. I wanted to place a copper line, so I'm going to select copper top, place, line. You also notice when you do that, Control-Shift-L does this automatically, but it changes how things are. And if I select this, you notice over here, that also got a white X in it. They both got a white X because they're on the same net. And so I can come over here and connect these two. And up here it says how, I pressed escape to get out of that, but up here it tells me how wide my trace is. And so if I wanted a thicker trace, I could say these are in millimeters, so I could say I want a 1 millimeter trace. Let's see what a 1 millimeter trace looks like. Okay, so that's what a 1 millimeter, this is a 1/4 millimeter trace that's up here, and a 1 millimeter trace. Okay, and so this is about how this would look. Let me undo my last one because I want to show you one other thing. I'm going to go back down to 0.254. Okay, I'm gonna do my Control-Shift-L, or up here it was place line, and I'm gonna start here. And let's say I wanted to go to the back for some reason. So it's pivoting on that corner right there, I can tell. I'm just going to come over here and select copper bottom. You notice the change, my copper change. I'm going to press escape, and it made what's called a via. A via connects us from one layer to another. Now, I generally only make 2-layer boards. I haven't gotten to the expert level where you need an 8-layer or 16-layer board. If you do ball grid arrays, you might need something like that. So I generally only need 2-layer boards, but you can have a whole bunch of other layers here. But this dropped it through the layer, put it over here, and then we made this connection. And the through-hole components, these are vias, okay? It doesn't show them. And now we can go and place or view our 3D preview. And now it shows the copper, how the copper is laid on there. The other thing that's interesting about this is that we have, is that all of a sudden all of the nets are correct. So if I wanted to, we could come up here, we could do a DRC and netlist check. Okay. And down here at the bottom, it says DRC and netlist check, everything's complete. If I were to come out here and delete this and DRC and netlist, it says, let me see, DRC and netlist, it still says that there are 0 orders. Let me see, connectivity check, all nets. And it says I have one trace of via that's not connected. So I put that back and everything's good. Now, one of the things I don't like about Ultiboard is if I try to move this guy, and it'll kind of move it this way. But let me do something that's really bad. Oh, and you can see it right there. I crossed over 2 non-connected nets, and it gives me these circles. And now, under DRC, it says that net 1 is connected to net 2. You can also just have it too close, okay? It's too close, maybe not touching, but too close. I don't know if I can do this with how this is, but you can get these too close to where it says, someplace in our design rules it says how close things can be. Well, that was a boring design. And also the components already existed, and so we have basically 3 cases that we can come across. One is, I guess there's 4 cases that we're gonna come across. And in order to illustrate, Okay. I'm just going to do it like this. The schematic diagram, which is going to be Multisim, and the footprint, this is Ultiboard. Okay, so I just did one where both the footprint and the schematic, they both existed. I just transferred them through. Okay, does not exist, exists, and does not exist, does not exist. Okay, so if we look at how this is set up, we just did number one. So I'm gonna go. Okay, we did that one. I think the next one I'm going to do is the schematic diagram does not exist, but the footprint does. And so that's the one that we're going to work on next. Okay? I apologize if this is super boring for the two of you out there who are actually watching this. But this will be good for everyone in the future. Hopefully you can give me some feedback on this if you want to type in comments or whatever as you go. So you may not quite understand what this means, and so let me give you an example. Here is one of my favorite components, MSP430 G2553. Many of you know this and love it along with me, and I'm going to do something slightly different because I've never done this one before, and I'm going to make so this comes in a few different packages. I kind of want to make this one. And I'm pretty sure that QFN actually works, actually exists. So the footprint. So I'm going to have to find the footprint. Okay, that's the first thing that I'm going to have to do. Okay, but this is not a component. If I search through I search through here for an MSP430 G2553, it doesn't exist. Now, let me show you one other thing. There's master database, corporate database, and user database. User database. These are all components that I've made. Okay, so if you look at every single one of these, that's a mounting hole, analog switch. These are all things that didn't exist, but I made them anyways. Okay, now, and I did this so that I could have some very specific stuff. And look, an MSP430 G2553 already exists. You can look at what the footprint already is. I can place that, and this is my already existent 20-pin G2553 with a footprint that's already attached. There's a 20-pin that's the same thing, 28-pin that has 28 pins, and the one that I want to make, and we'll just put this over the side, is this one. I want to make this one right here, the QFN package. This is a quad flat, no lead, I think is what the N stands for. And someplace on here, and it's 32 pins, okay? Someplace on here, on the data sheet, is right here. It starts telling us about footprints and footprint layouts. And so you can kind of see that we have the DIP package. It's pretty standard. You should be able to find that footprint, by the way. DIP 20, and it is pretty common. A TSOP 28, TSSOP 28 is a pretty common package. And a TSOP 20. Those are two of the packages. And then we have the QFN package. And what they do is at some point, right here, they give us what the footprint layout should be. And I know we're not mechanical engineers, but we have to start reading the stuff. So I've never made this one before. I've actually never used the quad flat N package, the VQFN package. But they give us dimensions for everything, such as the spacing that they have here. From each one is 0.5 millimeters, and then they do this 28 times. They have 1 millimeter. They have let me see. It tells what the spacing on each one. That's 0.6 millimeters. This is 0.25. So that gives you an idea of what this is going to look like. Okay. What doesn't exist is the actual microcontroller. So let's find it. I'm telling you that it should exist here in Ultiboard, and I'm just going to compare it to over here. Over here, we're going to go into the database. In the Ultiboard, we're going to look at, let me get this smaller first, and we're going to go in, Tools, Database, and this is where it gets ugly. I'm going to go, so once again, we have Ultiboard Master, Corporate, and User. Corporate is if you have a you have a network server, everybody can share the same components. But this is Ultiboard Masters, where I want to find something that already exists. And the problem about this is you gotta find it, and there's nothing really good about this. I think I'm going to go into, in this case, not through hole, but surface mount. Okay, and I'm really not seeing it anywhere in here. By the way, there's like something up here that allows you to search subcategories. Mine is gone because I've already. But you should be able to search all subcategories. And so I don't see. Maybe it could be that we find it here. QFN, and I'm going to do a star on the QFN, meaning it's a wild card. And we can look at all of these, and maybe we can find one that has 32 pins. There's one with 33, but that's rectangular. These ones all have a ground pad in the center. Okay, so we've got QFNs, and I don't believe, I mean, we can go back here and look. I guess they do. They've got a ground pad in the center. So we're going to use that ground pad. That's fantastic. So what we're going to do is we will go back to here and see if we can find, it's going to be a 33. So that was actually one of the first ones that we came across. And I'm going to show dimensions, and then I'm going to zoom in, and I'm going to see if there are dimensions. So they're saying from there to there is 3.5 millimeters. And we come here and we look at the spacing between this. 3.45 millimeters, that's really promising. That's right within what I would think is our spacing. And if we did the math on this, each one of these is 0.5 millimeters between them. So 1, 2, 3, 4, 5, 6, 7. So 7 times 5 is 35. So what's cool is this already exists, and we're just going to use this one. The big trick is that. I'm going to copy that right there, okay? And we have to remember what this. So I'm just going to leave this up for right now, okay? But this looks like a good package. There may be a whole bunch of them in here, by the way, that serve that purpose. In other words, this may be another one, and I'm not going to. We'll go back to the first one, but let me see. This one looks really good too. So TQFN, I like that. Okay. The only thing that might be different between them is how thick the three-dimensional thing shows on them, or something like this. So that's great. We've got this. I'm just going to leave this up, and we're going to head back to Multisim. So here's Multisim. I have to now make a component. Okay. So the footprint lives. The schematic does not. And so this one has a tool and a component wizard, and this is where we're going to make the component. And what I'm going to do here is I'm going to call this component the MSP 430B G2553 VQFN package 32. Okay, so it's 33, but we'll call it. I don't want to do any simulation with this. I don't know how to simulate microcontrollers. I'm going to do layout only. I want to select the package. So this is what I need to know where this is. So I'm going to select the package. It's going to come in here. I'm going to use the user database, and I don't have any way of searching for this. You can filter it by number of pins, and then scoot down to where it says 33, and you can okay, so, and that's one way. You can use the filter option up on the top right there. Oh, and there are only a couple 33 pinners. Okay. Look, there are only a few. Okay, and so the one that we want, and they named these all sorts of weird on this, was LQFN. That one might work. But I've already vetted one of these. WQFN. So we're going to have to look for the one that was PQFN. And the reason why we're not seeing it is because that's actually a label that's over here someplace. Okay? Someplace they have a label over here, WQFN. So that could possibly be it. Okay? I like it. If we want to, we can zoom. We can't really zoom in on this one. But let's go and look and see if that's the right one. And I'm not sure. What's funny about this is, oh, this is the Ultiboard footprint, so that's what I should have selected. Ultiboard footprint. We can come back here. Okay, so there it is. We're going to verify dimensions 3.5. I think that's the first one that we came up with, and so I like it. We're going to select it. And you can check all the dimensions, by the way. I was very, very fast about that. So I'm going to say the number of pins is 33. I'm going to edit this one, okay? So I'm going to edit it, and there's lots of reasons why I'm going to edit it. But what happens when you edit is we get to edit what it looks like on the schematic. I want this thing to be huge, okay? So I'm going to edit. Got to resize my boundary box. I'm going to make it look approximately how I want it to look in real life. I don't know why they do two separate boxes. It's kind of weird. But this is where I'm going to come back here to my data sheet. I'm going to go to the very first page, or very first few pages, and this is going to be my reference, because this is the schematic, remember? This is the schematic of how it looks. And so, as we look, we have pins 1 through 8 on this side, and we can resize as we go. 1 through 8, and so I'm just going to grab 9 through 16. Let me grab 17 and throw it over here. Okay, I've got 9 through 16 on that side. I can grab these guys and move them down. I just want to make it, as close to the schematic, what the schematic looks like as possible. And that's because it's going to help us in the end. And then we have one stray one out here, which is 33. I'm going to put out here on this weird corner. 32 through, what is this, 25. Grab those, put them up here. Okay, have these guys I'm going to move up. Okay, that way we have all of our pins that are on there, and we just have this weird stray 33, which is the bottom pin. And then we're just going to close that. Save changes, yes. Okay, and we go on to the next thing. Now it wants to name the pins. So that's where the thing on the right becomes very helpful. I'm going to come over here and I'm going to actually zoom out just a little bit. And I'm going to say this is pin 1.1. I'm just doing a one-to-one mapping. This is 1.2. Pin 1.3, pin 1.4, pin 1.5, pin 3.1, pin 3.0. And then this is NC. And so NC1, it doesn't allow me to double name, so I'm just going to call that NC1. Pin 9, which is where we're at, is pin 2.0, pin 2.1, pin 2.2, pin, oops, let me go back, I did that wrong. Pin 2.2, pin 2.3.2, pin 3.3, pin 3.4, pin 3.2.3 should be on 16, pin 2.4. Okay, pin 2.5, pin 3.5, pin 3.6, pin 3.7, pin 1.6, pin 1.7, reset, test. Pin 2.7, it says X out, but I like to call it pin 2.7. Pin 2.6 is the next one, and then we have AVSS, DVSS, AVCC, DVCC, and pin 1.0 and NC2. Then we also have this one, and kind of the question is, what is that connected to? And I think it's going to be ground, okay? In fact, I know it is. Well, it's not, but it's kind of a question of what that one's connected to. And so let's go down and find out. So we're going to find out that down there on that diagram, maybe. And they may say something like exposed thermal pad, sidewall, pin index area. And so they don't really say what 33 is used for. Okay? And that kind of bums me out. A really good diagram would tell you exactly what pin 33 is for. And so it's a thermal pad, though. It's meant to suck heat away. I'm pretty sure that we can connect it to ground. But I'm not going to. I'm going to leave it just as its own. I'm going to call it therm. All right. Now that we have thermal up there, we can click next. And we have to map pins. This is where we physically, when we think of Ultiboard, all the pins that are numbered, and these are numbered, by the way. So if we zoom way in, someplace in here, it does tell us what pin that is. This happens to be pin 1. I just know it, and I can't see it, but I know this is pin 1, and it wraps around this way. Somewhere on here, it should tell us what pin each one of those is. But we know that this is pin 1, and that's one of the reasons why we labeled it properly, is so we can just map pins, and it's really nice because we can just auto-assign. It just labels them in the correct order, goes all the way through, and you could go through and verify if you wanted to. And we're done. Now it just wants us to save it someplace. I'm going to save this in, let me see, microcontrollers. I'm putting right there under MSP 430. We're going to finish it, and it's going to automatically place this one. So we'll delete this one. And so hey, while we're at it, let's use these guys for something useful. I don't like that one anyways. I know that my reset needs to go someplace that is useful, and I'm also going to, why not? We're going to place a pin header. So going back to not the user database, but the master database, rectangular headers is the group that I want to go to. So these are under connectors, and then header test. And you just have to learn where all of this is at. I don't have a good way. And I'm just going to do a 1x10. Okay. And did not place component. Okay, and you can tell that it uses a package that's a generic header. Okay, so that's there. We're going to flip vertically. There. So I have pin 1 up there, makes me feel a lot happier. And what I'm going to do is I'm going to make pin 1 VCC, which is 3.3 volts. And I'm just going to hook analog and digital VCC together. And reset pin we want to be pulled up. VSS, let's just put it there. And this is all getting rather ugly. I'll show you a trick here in just a little bit. But we also want to do test and reset out here, so we can program the darn thing. Okay, and maybe you want to swap those here. I like it better when we swap them. That way in the layout, it might look actually something like this. Another reason why we want to have our layout approximately equal to this. And so let's transfer this. We have our resistor, we have our chip, we have a header, which we've never seen before, and now we're going to transfer to Ultiboard. It's going to give me a problem because I've already designed it. It says okay, can't do that because it's already open. This is open, and I'm going to close this out. No, I don't want to save it. And I'm going to go and transfer and transfer it. I'm going to save it. It's going to say yes, I do want to do that. Tells me all the nets. You notice even just with those few connections, there are way more different connectors on there. Oh, I lost a viewer at some point in time. This must be really boring. This must be, I think I'm down to 1. But you can see there's way more connections on here now. I'm going to say OK, and we get our cluster of stuff up here, and I'm just going to grab all of that and move it and orient this how I want it to be. Maybe I want to control R rotates us, and maybe I want it to rotate it like that. I like that, and maybe I want to rotate this. And you notice that has an arrow down at the bottom of it. Okay, now I never do this, but I show people so that they will make this mistake. I can come up here, I can go Tools, I can go Auto Route. And this is simple enough. Well, it didn't do it. It has some problems, okay? And so it couldn't auto route. That's why I never use auto router. Well, darn. Okay, I'm going to do my thing, and I'm just going to start linking. So you notice I connected that one in, and that linked over here to 5. And that means, and I think I made a mistake because I don't want the reset pin and high to be connected together. So I made a mistake. I recognized it when I was in Ultiboard, and sure enough, I did the wrong thing. It's right here. That's a goof up. Okay? Instead, I wanted to be connected over here. Has these horrible lines. We can clean those up later. Don't worry. You can save. But now, in transfer, I'm not going to make a new one. I'm just going to forward annotate. This tells me my changes. And the cool part about that is it made the change here without changing a whole bunch of other stuff. And so as I look at this, yeah, I like that a lot. Okay? That's what that's what this looks like. Maybe I want to rotate it like that. Okay. Now, place, line. Here, there, here. I almost did that wrong. I don't like it. Control Shift L gives me my line. I don't like how the lines lay out. It's giving me an error here. It's saying I'm too close, and there's nothing I can do about that. Someplace over here under Options, we can look at PCB properties, and we should be able to look at grids and units. Let me see, design rules, and we can say minimum trace width. Let me see, spacing, trace width, maximum trace length. Let me see, clearance to traces, 1/4 millimeter. And I think that that's the problem. So I'm going to crank this down to 2. To 0.2 millimeters. Remember when those were spaced, they were spaced by 0.25, and this is 0.254. Okay. Apply. Okay. It's still giving me the error, so I've never been able to figure out how to get rid of that error once it starts up. But it's going to tell me those are too close, and I don't know if I really care. So Control-Shift-L can drop that guy there. Now there's lots of different things, rules as far as printed circuit boards go, that people like to follow. These aren't real rules; they're just, you know, how they like to design them. There are some things that are kind of handy. I can just do that. And then we have one. So here I cannot get from there to there without a via. Okay? So I'm going to start there. Switch my copper bottom. And then I'm going to remember, oh yeah, that's a via over there. Now the big problem that the big mess that I just made is these parallel vias are close on top of each other. Vias are right on top of each other. And there's no way on top or bottom that I can get from there to here. So I don't like to have this. I'm showing you as an example, but if for some reason I was trying to get this way from someplace else, I wouldn't be able to get through these, either top or bottom. There's just no way. So I don't like to do that. If I were to do this, I'd bring it up here and bring it over that way. I could put a via in the center sit here. We can copy and paste our via. We can paste vias. We can place them. A via is right there, and so this brings up where I don't know where it brought that option, but someplace it's that option. Okay, from copper top to copper bottom, and it placed it. We can change the size on these. Under general, we can say how big it is, layer settings, thermal relief, general attributes. So under general, we can make the size. And here's, I guess that's where the clearance is. But this is going to be its measurements, or this is where it's at, so I can move it to like 12 millimeters, apply, and it moved that via over there. You can see. The via itself, use the design rules, or we can make our own. We can make it bigger. And we can make the inner diameter smaller and apply. And you can see this via just changed. Okay? So you can make vias whatever you want. It's probably best to use their defaults. The board houses that you order from are going to put limits on how small your vias can be. And they're usually pretty good. And they're also going to put limits on how close these tolerances can be. Now, you could do these tolerances just fine, as is, okay? Slop it together like this. And if you got too close, maybe something that they'll do is they'll get mad at you. And they'll either get mad at you, or they'll just say, you have no guarantee that these two traces are not going to be connected. So that's all dependent upon what you want to do with that. But we're pretty much done with this, done with that portion that we just did. So, we made one where the schematic part does not exist, but the footprint exists. Now we need to make one where the schematic exists and the footprint does not exist. I don't think this exists. I've never, ever come across something where I have a schematic, but they don't have a footprint for it. And so I'm not going to do that one. Instead, we're going to do both. And the way that we're going to do both on this is I have another part that I like, and I don't know where the schematic exists, and I don't know that anything exists. So we're going to go and find the PDF data sheet for this. This is an accelerometer. It's a little teeny tiny thing. And let's look and see how many pins it has first of all. And I'm going to make the footprint first in Ultiboard. And so I don't have much information at first on this. It's all, I've used this before, I've made this footprint before. This is telling you how they come out of the package, so your pick and place can drop them in the right place. And so here's our diagram. It's got 12 pins, okay? And this is a little bit weird. So tools, part wizard. So this is Ultiboard. We're going to open up the part wizard. Is this a through hole or a surface mount? Well, this is a surface mount. Which one of these does it most look like is kind of the thing. You can start from scratch if you want as well, But this kind of looks like that one. I think it most closely actually resembles this, a QFP, a quad flat package. It's not quite, but it's pretty close. The only problem with the quad flat is I can't make these. It's always going to be quad. So I've got to make something where it's going to be odd. So where I can do them. So it might have to be a PLCC. We'll see if we can do it with a quad flat. I don't see anything else in here that's too interesting. So we'll try it with a quad flat. I don't know if they'll let me. Let's see if they let us do different number of rows versus. Yeah, they'll let us do this. So we'll use a quad flat package. And so first they want to know what the outside of that looks like. And we look here and I go, oh, it's 2 millimeters. And units, yep, are in millimeters. 2. Okay, so that's how big it's going to be. We're going to have a little circle where that belongs. We can do 3D offset. That tells you how much off the board it goes, which this one is really low, like 0.2, if that. Corner cutoff, I don't have much. Diameter, etc., etc. 3D height on this. If you want to be specific about it, they will tell you what the 3D thickness is on this someplace. And this is the layout there, but here it is, 0.82. I'm happy with 1 millimeter. That's close enough because I don't really care about that. Next, they're going to ask me what these pad sizes are. Well, that's where we're going to use this diagram. And the X looks like it is 0.28 millimeters. And the Y looks like it's 0.41 millimeters. And whoever's calling is going to have to call back. We're going to pause for just 1 second. My apologies. Oh, that's probably for audio. Okay. Okay, Mr. McCord. Mr. McCord is in my next door room. How am I doing so far? Too fast?
Not bad.
It's pretty fast.
Yeah.
Okay, so this one says 12 by 12, and I say no. The number of vertical pins on this is 4. Number of horizontal pins is going to be, oh, I got that wrong. Vertical pins is actually, that's right. Number of horizontal is going to be 8 for this particular one. Distances between pads. Okay, between the A, so there's a little diagram on this. So A, that's the spacing right there, and they're saying that all of these are 0.5 millimeters. Hey, cool, it's already there. Okay, the other one is distance between C, between this way, and we can look on here and maybe get an idea of what that's supposed to be. And I really don't have a good idea on that. Let's see. 0.5, it's about that. There might be a better diagram here. Ha! Here. This gives it to us. So they're saying that's 1.5. That was the wrong one. Okay, that's the wrong one. So that one should have been looking at this diagram. I'm not sure. That might be 1.5 as well. Okay, so I'm pretty sure that that's pretty close to it. If we were to do the math on this, we'd find that spacing is like that. Okay, so I'm going to go with this, that's the spacing there. This is pin 1. It's horizontal. They do, their pins on the back of their chip are actually square, but their footprint recommendations are rectangular. It's kind of a goofy thing. And just because of that, we can make C just a little bit bigger. There, that makes me feel better. Less chance of a bridge right there. And they also have this ordered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hey, it looks perfect. You can change this. You can go counterclockwise or other things. That's going to work well. Okay. So this is what our footprint looks like. We're going to save it. by just doing Control S for save. We're going to go to the user database, and I'm just going to call it whatever I want. This is going to be the BMA 280 XL. And this is a custom footprint. This just doesn't exist, okay? And this happens a lot. We go through the same process for through holes for this entire thing, but now this exists in my user database. So we're going to come back to Multisim. So now, if we look at the diagram, does not exist. We just did exist in the Ultiboard. It's the first time that we've done this, so that's kind of new. Okay, I'm going to do here again, Tools, Component Wizard. We've already done this. BMA 280 is what I'm going to call it. Layout only. Next, I'm going to select a package. We just made it. It's under User Database. Has 12 pins. There aren't very many in User Database because I've made those. I haven't made thousands upon thousands that exist otherwise. I like that. How many pins are there? There's 12. Next. I can make this layout a little bit better. I'm not going to, well, I'm going to. I'm going to take the time. Edit. Resize boundary box. And in this particular case, all I'm going to do is, rather than make it look perfect, I'm just going to make it big enough to where I can put words in there. Okay, and now we need to name the pins. Okay, so this is where it gets tough. Here we go, pin 1. So I'm just going to follow their thing. SDO. SDA, SDX, they call it SDX. VDDIO, NC, we'll just call it int 1, int 2, VDD, GNDIO, GND, CSB, PS, SCX. That should be all 12 of our pins. Map the pins. Once again, this is connecting our, and I've laid these out right, but this is connecting the actual footprint pins to the schematic pins. This seems a lot quicker now because, well, we're used to it and we did it already. And I'm going to put this under an advanced peripheral, add family, and I'm going to say this is under accelerometers. Finish. And there's our footprint. And now if we transfer this, forward annotate it because it already exists. Save that. It adds in our new footprint up here. Look how tiny that is. We thought the QFN was small. Look at that. So, and I don't have any interconnects. I didn't take the time to do that. And so we can do that if we want to. I just don't have the time to go through all of this. But I'm going to show you one thing. So let's just do this for a second. This got really sloppy. I'm going to place an on-page connector. I'm going to connect it to DVCC. And I'm going to call this VCC. This does a few things for us, which is really nice. And then we can do this. And then over here, well, I'm going to copy it and paste it. It renames it. I have to go back and call it the original one, which I think is kind of annoying. I wish you'd just copy and paste the original. So that's connected there. And maybe I want another one up here on VDD, so it's VDD for this one. If you're confused, go back and look at the diagram. Anyways, VCC, I have to rename this, yes. Okay, and then we can do the same thing. I'm going to do the same thing for ground. Here. Doesn't bother me at all to do this. But this cleans up our diagram really well. Okay. And I'm going to rename this to GND. Maybe I'm going to move that off to the side so I can tell the difference. Put this here. Rename that one. Okay. Okay, so ground is there, and then we can even do it here if we wanted to. And what do we call that one? That one was VCC. Okay, but that cleaned it up a lot, right? We just did these onboard connectors, and now when we transfer it to Ultiboard, or I'll forward annotate it. So it didn't change much, you know. But what it did do is it made it to where it was cleaned up really well on the schematic. We just have those two other things connected. This doesn't like that, so I changed the schematic just a little bit. I'm like it's better. So there's lots more to Multisim and Ultiboard, but I'm at my end of my hour, and I think that we've learned what we wanted to learn by doing this. You get the idea. There's lots of nuances on doing this, and lots of ways that we can make it simpler and more complicated. Let's just leave it at that for right now. The biggest thing that I can say is somehow get to know the footprints. If you can understand the footprints and how they attach to your schematic, then this becomes a lot easier, and this becomes really fast, especially once you get a catalog of parts that already exist. We can just place from my user database a part that I've already made. Okay? Can come through here and replace. You can put another accelerometer on the same board. So I'm going to leave it at that. I encourage you to I'm going to save this video and send it out to you. I encourage you to give me comments or suggestions on how I could have done this better. My assumption is that as you watch this, at least not immediately, that you pause and do this along with me. I think that would be a really smart thing to do. But then you're going to have questions. How did you do this, or how did you do that? You're just going to have to watch me rather slowly, I guess. So thanks. Give me comments and feedback. I appreciate it.